Okay, we're going to take a little bit of time here to go through Hydrocad in addition to the two videos already put out regarding how to deal with ponds and with subcatchments. So I'm going to go ahead and start a new project here. And just kind of show you, again, start a new project here. I'll call it temp 8. Remember, we've talked about how to do these things. I'll show you the last two things later in the last video, but we're going to go through very quickly. These are generally self-explanatory. The diagram, the project setting, the diagram, the node, which is usually done with a right click on top of a node. Looking at things, showing you typical constructions, what they look like. Pretty useful there. Reinforced concrete pipe round. For instance, there's that 12-inch pipe, right? And showing you sizes, internal and external diameters, settings, everything's like that. So pretty useful. Giving you the width, you can do it based on area. All kinds of different calculations there. Definite improvement of what they had in the past. As I stumble across this software, which shifts, I'm going to say twice a year. So, right, showing you unfortunately Wisconsin is not here, but they've got different curves for different areas. Once again, New Jersey. This is a cumulus mass distribution of the rainfall. Depth, intensity, you see all that stuff there. Printing, very often a clipboard or file. Settings here, and these settings are off here on the right, so we're going to take a look at those in a second. And then your general help. Across here, toolbars, etc. Particularly of great importance is the calculation one. Current messages and print. Out here, this is the one I want to point you out. Here, unit settings. I'm right clicking, nothing's occurring on that one. Land use settings, report land use, report pollution load. Lots of stuff that you are not going to get into, but realize that you've got an incredible amount of ability to take data off of your cadastral maps, land cover, off of photographs, and input. Do a lot with this program. Diagram sizes. You'll see this is the one I want to point to because this allows you to essentially bring in a JPEG, if you would, of your project and place it. I'm not going to do a JPEG, but we'll go ahead and see if I can find some picture. See how it works in there. Boy, it brought it in. And so this gives you then the ability to once again play around and put some symbols on that. You'll want to feather this, but the fact is that by going back here and putting the symbol size to something, maybe something small, and now if I bring in a subcatchment there, I can label that up. Definitely worth great improvements over the past, right? Okay, great improvements over the past is just in that ability to bring in a background, exporting information. You see CSV files for your time step analysis, general settings, particularly the sound, printing stuff. Particularly maybe sending to a PDF file or a JPEG file, and then what we had down here below. So that's quick 5 minutes. That kind of shows you all of the rest of that. I'll show you the last two things. One is the link. Right click, edit. This is if you've got information, hydrograph information or flow information that you're going to just bring in from something else. This can be used to make a backwater if you're flowing into something with a fixed elevation, kind of game the system if you would. So that's link and reach. Right, more or less describing pipe reach is then only for open channel reach. So if we go here, a parabolic channel, what does the section look like? The profile, tailwater, and most of this you'll hear in terms of the reach is already in the definition of the pond outlets. So that essentially, we're going to remember finally that indeed we're going to deal mostly with subcatchments, which are defined by area, imperviousness, and time of concentration, and ponds, which is we're going to use for everything. We won't use the catch basin, we'll use the detention pond always, and they are defined by a set of contour lines in custom stage data is the way to go about doing that, and a set of outlets, with always including an overflow at the top as it be either a broad crested weir or a sharp crested rectangular weir. In other words, water that will flow out of the system eventually will find a high point and find its way out. And then generally there'll be one or two other outlets going up through the pond. There might be a pipe on the bottom, a pipe in the middle. There might be a pipe on the bottom, a small weir off on the side, and then eventually a major weir where it goes over the top of something. Some of these other things you'll learn to play with later, but they're not so important. The important thing to do with is to deal with in a pond, define its, I'm right clicking again here, define its contours and the outlets. Alright, that's the last kind of review here of the mechanics. We'll do one or two projects and put it out here so you can see how this works. A great thing to do with this would bring some aerial photography in, because this is really a conceptual deal here, and then tie eventually that aerial photography to what your plan would be when it was drafted in a design engine. Thanks for listening.